In the final module of Chapter 10, we'll look at binomial pricing options on other assets. So we'll be more explicit about currencies and dividends on stock and stock with indexes, on indexes and so forth. So the model we developed so far can actually be adapted relatively easily. The difference is in the construction of the risk-neutral probability, that ultimately, in each case, we are going to be replicating the option with a position in the underlying asset and in T-bills. And the implication for that replication is when we do the algebra, we'll find that the risk-neutral probability P star will be different in the different cases. So we'll examine options on stock indexes, which is basically a stock with a continuous dividend, currencies, bonds, and futures contracts. We won't spend much time with bonds because the model for bonds will be dealt in more detail in a later chapter. So let's look first at a stock index. We've already done some of the preliminary work assuming a continuous interest rate or a continuous dividend rate of delta in the earlier construction module. And in here we're going to apply it in an example where, as you can see at the bottom, we're going to price an option where we have a continuous dividend rate of 3.5%, same volatility, 30%. We're going to split the year up into 1/3 periods and have a maturity of 1. So we'll have a 3-step binomial lattice with a risk-free rate of 5% and a volatility of 30. We'll have a strike of 100, and the initial stock is worth 110. So here's our lattice. And again, we can confirm how the up and the down scenarios work. So for example, U is equal to R minus delta, so R, so it's E to the, and R was 0.05 minus 3.5 was the delta. H was 1/3. And then we have a plus, a 30% volatility, and a square root of 1/3. Similarly, the down return is exactly the same expression, but it has a negative on the vol term. It's minus 0.3, square root of 1/3. And with those two factors, we can then develop this table over the 3 periods. And you can now see, here's a call exercise with a strike of 100, you can see. And notice now that we actually have a period where early exercise is advantageous. And this is not inconsistent with our earlier work because this is now a stock that pays dividends. So here's a period where the exercise value of 57.10 exceeded the expected present value of the future state exercises, which was 87 and 32. So if we wanted to do this in a bit more detail, the upstate, we saw the expression a moment ago, would calculate out to 119.51. The down return in this example would calculate to 0.8452. And then we have an accumulation factor, e to the r minus delta h, is a little bit over 1. So we can now calculate the P star, and that would be e to the r minus delta h minus d over u minus d, and that calculates to be 0.4568. We have a risk-free discount factor at 5% of around 0.9835. And then we can proceed in calculating the delta in any one of these states as the dividend yield present value of options, Cu minus Cd over U minus D. So that in any state we would calculate the delta that way, and in any state we would calculate the associated B as e to the minus RH, which is that discount factor, and then we have a UCD minus DCU over U minus D. And we could do that. So in any one of these states, we could calculate the delta and the B from these two exercise values, delta and B from these two exercise values, and so forth.